We are now going to start working with arithmetic sequences. I would like you to take a moment and in the next 4, can you please predict for me the next 3 numbers in each pattern? I know we're going to start with a pause right away. I'm asking for you to find the next 3 numbers in the pattern. Please pause the video. Thank you for pausing. Take a moment and at least compare your answers to mine. Did all of our patterns end up with the next 3 numbers being the same? I sure hope so. A couple things I want to talk about. In the first pattern, I would assume you noticed that they are decreasing each time by -2, etc. In the next pattern, though, we had a +3, +2, +3, +2. Oh, well, that's a neat pattern. Add 3, add 2, add 3, add 2. That's cool. Here on this one, we have +2, +2, +2, etc. So that worked. What did you guys come up with for the next one? I see fractions and then whole numbers. I'm thinking most of you were able to see that I started adding by 1/3. 3 of these are arithmetic sequences. An arithmetic sequence is when it changes constantly at a same rate. It will be increasing or it will decrease at a constant rate. I realize this one has a pattern, but it is not constant. So this one is an arithmetic sequence. This one is arithmetic sequence. And so is this one. The second one on the page is just a fun pattern, but it does not increase or decrease at a constant rate. We will be working with this formula or equation to help answer some questions. We first need to figure out what the parts of this mean. A with a little n there describes the nth term. I'll explain what that means in just a moment. A with a little 1 will be the very first term, and by term I mean number, in a sequence. So the first term in this sequence is 2/3. The first term in this sequence is 2/3. N stands for the term number. This would be the first term. This would be the second term. This digit here is the 4th term in the sequence. That's what the N represents. Finally, D. That is called the common difference. Now, difference is usually with a subtraction word, but it is how the sequence is changing at a constant rate by increasing or decreasing, adding or subtracting. This is a very straightforward equation or formula to use. Let's just apply it to an example below. So I'm giving you an arithmetic sequence. First, let's figure out what is the common difference. How are the numbers going from one to another. How do I go from 7 to 11 to 15 to 19? I'm adding 4. So my common difference is 4. All right. Our first term, I think you can see that by just looking at the sequence, is 7. The term number I'm looking for is 25. I want to know if I were to list 25 numbers in this pattern or sequence, what number would fall in the 25th spot? This answer right here is a to the nth. Okay, so I will use this equation. A to the nth is what I'm looking for. My first term is 7. I want to know the 25th term. And my common difference is 4. We just need to follow what we know about order of operations. (24 times 4 is 96). So in this sequence, 103 would be the 25th number in that pattern. Take a moment just to review what we did. Where did we come up with our numbers? How did we put them into the equation? And how did we arrive at 103? Pause the video. Take a moment and look at what we just did. Thank you for pausing. Okay, we'll practice one more time. In the upper right-hand corner, I gave you the equation again. This time, I'm looking for the 32nd number in the pattern. So let's see, how are we going from one to the next? I'm adding 5 each time. Okay, so my first number is 12. Plus, I'm looking for the 32nd term. My common difference is 5. So now we just need to use order of operations and figure out the solution. So 12 plus 31 times 5. I would have 12 plus 155. The 32nd number in the pattern would be 167. Pause the video and find the 17th term in this equation for me. Be very careful, pay attention to the common difference. Thank you for pausing. I substituted my numbers in for the different parts of the equation. When I was done solving, I arrived at -50 to be the 17th number in that sequence. Now we're going to make a very general statement so that someday if I say, here's a pattern, tell me the 100th number in the pattern. Tell me the 19th number in that same pattern. The 51st number. We will have a general rule so we can calculate that. Again, I will just use this in the equation. So my first number is -8. I'm looking for the nth term, so I'm going to leave n in as my variable. How does this pattern change from one number to the next? We are adding 9. All right, from here we just apply what we know, distribute. Then we will combine like terms, and I end with 9n minus 17. So now if I asked you to find for me the 100th term, you would do 9 times 100 minus 17 and 883 would be in the 100th number spot. If I asked you to find the 85th term, I would do 9 times 85 minus 17, 748. This would just give me the general rule so I can find any number in the sequence. Pause the video, mimic what we had just done here, and try one by yourself. Thank you for pausing the video. This would be my general rule. Again, if I decided I wanted to know what number is in the 10th term, I would put 10 in and solve. 12 times 10 is 120, plus 7 is 127. If I wanted to find the 15th term, I would put 15 in, multiply, add 7, and I get 187. So this is what I'm noticing if you look at the table over here. The first term is 19, so when I put 1 there, I get 19. The second term is 31, so if I put 2 here, I get 31. The third term is 43, so if I put 3 here, I would get 43. So fill in the table for me. If I put the 5th term, what would I get? We did the 10th and got 127. Calculate for me, what are we missing to get down to the 44th term? Pause the video, please. On the right, I hope that our tables look similar. As we are learning about linear functions, notice that for every x in the domain, we are going to have a different y in the range. This will be linear. It passes the function test. If we were to graph it left to right, it would pass the vertical line test. Okay, we can skip this part. I'll put the answers in just a moment. But by filling in the table, we kind of completed that. My final question is, 200 is the blank term, I spelled that wrong, in this sequence. Okay, so I am giving you a of n this time. I'm asking you to find n. When I look at this sequence, I see that 1, the first term is 24. So I need to work algebraically backwards in this equation. So I'll substitute what I know. I know that 200. Now what is our common difference? How are they? This should be a 35. My apologies. How are we going from one to another? We are multiplying or adding by 11. This is just turning into a fancy two-step equation. Combine your like terms. Oh, plus 13, used to having the equal sign over there. I will subtract 13 from both sides and get 187. Divide by 11 and equals 17. So if we continued this pattern, the 17th number would be 200.